In this video, we're going to be looking at how can we find the derivative of the sine of x. We're looking at d sine x dx. What could that be? Well, actually, let's begin by using the definition of a derivative. So this is the limit as h goes to 0 of the sine of x plus h minus the sine of x, and this is all over h. We've seen this before. We've not seen it using a sine function, and the trick for handling this is to remember back to Algebra 2 trig when we saw formulas that helped us to make sense of what does it mean to look at the sine of the sum of two angles. And if you remember some of those formulas, we can rewrite the sine of x plus h as the sine of x times the cosine of h plus the sine of h times the cosine of x. This was called the sum of angles formula for the sine function. So now we're going to replace this sine of x plus h with this expression in a substitution. So now we have, this is the limit as h goes to 0 of, I'm replacing the sine of x plus h with this. So we have the sine of x times the cosine of h plus the sine of h times the cosine of x, and then there's this minus the sine of x, which I'll write right here, minus the sine of x, and this is all over h, like this. Okay, what will we do with what we have on top? Well, I just want you to notice that what I have here is I have this minus the sine of x. In order to move that around a little more easily, I'm going to change this minus the sine of x into a plus a negative sine of x, so I can use the commutative property and move it over here closer to this sine of x. You see, I'm trying to line this up so I can factor out of sine of x. So I'm going to bring these guys together. I'm just going to rewrite it like this. So now I have the limit as h goes to 0 of the sine of x times the cosine of h plus a negative sine of x, and then there's adding on this guy, plus the sine of h times the cosine of x, and this is all over h. Alright, well, now these first two terms have a sine of x in them. Can you think of something to do when two terms both have the same value in it? Maybe we can factor that sine of x out. So we have the limit as h goes to 0 of the sine of x, which I'm factoring out, and on the inside we have the cosine of h minus 1, and this is plus the sine of h times the cosine of x, and this is all over h. But notice what we have here now. This is, we can actually split this into two different terms, right? By rewriting it with this h and splitting it into two terms. This is the limit as h goes to 0 of the sine of x times the cosine of h minus 1 over h plus the sine of h times the cosine of x over h. And what happens as h goes to 0 of these two terms? In a previous video, we showed that when as the limit as h goes to 0 of the cosine of h minus 1 over h, this goes to 0. So it'll be the sine of x times 0, and that'll just be 0. Plus, well, take a look at what we have here, this part. The sine of the limit as h goes to 0 of the sine of h over h. Do you remember that this goes to 1? So it's 0 plus 1 times this cosine of x. And of course, 0 plus 1 times the cosine of x is going to give us the cosine of x. And that is exactly what the derivative of the sine of x is. In fact, I'll write that result over here. D sine of x dx is equal to the cosine of x.